Greetings to you all. Star e-learning platform welcomes you to a chemistry lesson. This chemistry lesson is intended to guide and provide academic materials or information to these candidate students. Star e-learning platform is found on these social media platforms like YouTube, Facebook, WhatsApp, and Telegram. Our Telegram group name is Star e-learning platform e-class. You can use this telephone number to connect with all our social media platforms. We shall readily be ready to serve you. Before we start our lesson, I want to request you one thing. Please subscribe to our YouTube channel. As you view these videos and as you share and like, please don't forget to subscribe here to this channel. Help us to increase our capacity in building this channel. Be part of the people that are going to build the success of this channel. So I request you to press that button of subscribe and subscribe to our YouTube channel. Our YouTube channel name is Star e-learning platform e-class. So when you reach there, search for any science material you need. We shall readily provide it to you. But please don't forget to subscribe. This is teacher Kadudeo. This is my third lesson on energy changes. You can reach us on this telephone number in case you have inquiries about our lessons. You have maybe some questions about how we do our services. I would request you to connect with this number. Give us a call. We shall readily be available to answer you. I continue to ask you to subscribe to our YouTube channel. Support us as we also do the same to your studies. In our lesson today, we are going to look at, we are still looking at energy changes, but today we are going to look at these four major objectives. We are going to look at the relationship between temperature and the heat capacity. We are going to look at the relationship between temperature and the mass of a substance. We are going to look at the how to derive the formula for heat supplied or heat absorbed. Then finally, we shall look at calculations on the heat supplied. Let us start straight away by looking at the relationship between temperature and the heat capacity. In my previous lesson, I remember telling you that temperature is a measure of heat energy. So therefore, whenever heat energy is added to a medium or removed from a medium, temperature always changes. So therefore, temperature always changes when a substance absorbs or releases heat energy. The temperature change depends on the heat capacity of a substance. So what do we mean by heat capacity here? Heat capacity simply means the amount of heat energy that is required to raise the temperature of an object by 1 degree Celsius or by 1 Kelvin. So that amount of heat that you need to raise the temperature of a given object or a given substance to 1 degree Celsius or 1 Kelvin, we call that one the heat capacity. For calculations, heat capacity is given by this formula. So heat capacity is equal to heat supplied in joules. Of course, heat is measured in joules because heat is a form of energy. So it is measured in joules. Divided by temperature. Temperature here is measured in Kelvin, or it can also be measured in degrees Celsius. Now, after looking at that formula, we can now form the units for heat capacity. So what are the units for heat capacity? The units for heat capacity are joules per Kelvin. The word per means divide. So we have joules divided by Kelvin. So the units for heat capacity are joules per Kelvin. Reason being, we are dividing heat in joules by temperature change in Kelvin. So we have joules per Kelvin. The heat supplied can be expressed by letter H, capital H. The heat supplied. Sometimes we talk of heat supplied, but in the same case, it can be heat absorbed. And temperature change, it can be expressed as dt or delta H. Let's continue. We are going to look at the relationship between temperature and mass of a substance. Now, temperature depends on the amount of a substance in grams or in kilograms. You can imagine someone heating different volumes of water. Assuming someone's boiling 1 liter of water and another person is boiling 20 liters of water. Which of those two people will make the water boil first? Or will make the water boil to 100 degrees first, because water boils at 100? I think that person, you are boiling 1 liter of water, that water will boil first than the one who is boiling the water of 20 liters. So therefore, temperature or change of a substance depends on the amount of a substance. The greater the amount, the lower the temperature change, or the higher the time, taken to raise the temperature of that given mass. Okay, that brings us to a term we call specific heat capacity. Specific heat capacity can be abbreviated as SHC. So what is specific heat capacity? Specific heat capacity here means the amount of heat required to raise the temperature of 1 kilogram mass by 1 Kelvin or 1 degree Celsius. The amount of heat you need to raise the temperature of an object of 1 kilogram by 1 Kelvin or by 1 degree Celsius, that amount of heat you require to raise that temperature to 1 Kelvin or 1 degree Celsius, we call that amount of heat the specific heat capacity. Specific heat capacity can be denoted by capital C, and it can be calculated from the expression below. So therefore, for calculations, if you want to calculate specific heat capacity, it is going to be the heat capacity divided by the mass. Hope you get me there. Now, when you look at this formula, I think we can easily work out the units for specific heat capacity. So, what are the units for specific heat capacity? The units for specific heat capacity are joules per Kelvin per gram. Those are the units for specific heat capacity. Reason being, we are dividing joules per Kelvin, we are dividing it with grams. The word per is the same as divide. So we have joules divided by Kelvin divided by grams. So it is joules per Kelvin per gram. So those are the units for specific heat capacity. We can look at a typical example. For example, the specific heat capacity of water is 4.2 joules per Kelvin per gram. Therefore, to raise the temperature of water to raise the temperature of 1 gram of water, to raise the temperature of 1 gram of water, I want to explain what this expression means. This one, I want to explain what it means. Now, to raise the temperature of 1 gram of water to 1 Kelvin, you need 4.2 joules of heat. So that's what that expression mean. Hope you get me there. So therefore, the specific heat capacity of water is 4.2. Okay, now after seeing the units for specific heat capacity, we can now come up with another formula here. We can make heat capacity the subject of the formula. So we are going to be making heat capacity the subject of the formula. If we do so, we shall come up with this expression here. So we shall have heat capacity equals to specific heat capacity in joules per Kelvin per gram times mass in grams. So that one now becomes our equation 2. So in our first equation, we saw how we can express heat capacity. This was our first equation where heat capacity was expressed by dividing the heat supplied by the temperature change, and in this case heat capacity is again expressed as specific heat capacity in joules per Kelvin per gram times the mass in grams. Okay, we continue. Now we have seen heat capacity being expressed in two formulas. So now, since heat capacity is the subject of the formula in both cases, we can now equate those expressions. The expression you see here, this one, is representing the heat capacity in the first case. This one is also representing the heat capacity in the second case. So we equate equation 1 to equation 2. Remember, we are deriving the formula for the heat supplied or heat absorbed. So we have said we equate equation 1 to equation 2. If we do so, we shall come up with this expression. Hope you get me there. Okay, so after doing that, now we can make the heat supplied the subject of the formula. If we try to make heat supplied the subject of the formula, we shall have to multiply temperature change dt this side. Then we shall also multiply it the other side. So temperature change dt cancels this side. It will cancel and goes the other side. So if we do so, we shall come up with heat supplied equal to the specific heat capacity times the mass and then times the temperature change dt. So we have derived the formula for the heat supplied or heat absorbed. Hope you get me there. Now specific heat capacity can be expressed as C. Mass can be expressed as M, and temperature change can be expressed as dt. As you see these expressions here, you're seeing temperature expressed as dt, and temperature in this case can be measured in Kelvin or it can be measured in degrees Celsius. The specific heat capacity is represented by C and can be measured in joules per Kelvin per gram. Then mass can be measured in grams. Okay, we continue. Now let us look at calculations on the heat supplied. We have question 1. Question 1 is telling us that 100 grams of water rose in temperature by 2 Kelvin. So the temperature difference is 2 Kelvin. Calculate the heat supplied to the water. So they have given us the specific heat capacity of water as 4.2. In my case, when I was introducing specific heat capacity, I've given you the specific heat capacity as 4.2 joules per Kelvin per gram. I've given you that, but in questions we always use what is given to us. If they have not given you that specific heat capacity, then you will have to use this because it is a standard value. Okay, so we have been given that. So we have all the values to use in our calculation. Let us look at the calculation. Now we have our formula for heat supplied. Our formula for heat supplied or heat absorbed, it is mc dt. We saw m stands for mass, c specific heat capacity, dt standing for temperature change. Now what do we have? We have mass, we have the specific heat capacity, we also have the temperature change. So therefore it is a matter of expressing those values in our formula. If we express them in our formula, we shall have 100 grams times 4.18 joules. I said the word per means divide. So we are having 4.18 joules per Kelvin per gram. So that's why we have that expression showing you that we are dividing those units. So we are having 4.18 joules per Kelvin per gram. Okay. We are going to see the reason why we are trying to expand those units. But anyway, let me give it to you. We try to expand those units simply because we want to cancel out the unnecessary units and we remain with the units for heat. I think you know the units for heat. Heat is in joules. We want to cancel out the other units that are not necessary representing heat energy. So we have written our units like that. Grams will cancel with grams, Kelvin will cancel with Kelvin. So we shall end up having 100 grams times 4.18 joules times 2. Then finally our answer is going to become 836 joules. Okay, let's continue. Let's look at question 2. In question 2 here, they are asking us how much heat is required to heat 100 cubic centimeters of water from 10 degrees Celsius to 20 degrees Celsius. We are given the specific heat capacity as 4.2 joules per Kelvin per gram. Density of water is given as 1 gram per cubic centimeters. When you look at that question, you're going to find that the question is silent about mass. They have not given us mass. So therefore, we shall use the provisions given to us and we calculate the mass. I think all of us we know that mass is equal to density times volume. So therefore, do we have the density? Yes, we have the density. Do we have the volume? Yes, we have the volume. So we just use those provisions and then we calculate our mass. Hope you get me there. Let's look at our solution for this question. We all know that heat supplied is given by mc dt. That is our expression. Do we know mass? No, we don't know mass. So we are going to calculate mass. So we have our density. We have our density, which is 1 gram per. I said the word per is the same as divide. So we have 1 gram per cubic centimeter. So that's why we are dividing the cubic centimeters, because we have 1 gram per. The word per is the same as divide. Hope you get me there. So we are having 1 gram per cubic centimeter times 100 cubic centimeters. The reason why we organize our units, we want to cancel out the unnecessary units and remain with the units for mass. Okay, so let us look at that. So cubic centimeters will cancel with the cubic centimeters and we remain with the grams. So therefore, mass is going to be 100 grams. So we have calculated the mass. We know the specific heat capacity. They have given us the temperature change. The temperature change can easily be calculated. You just get final temperature. I mean initial temperature minus the final temperature. Our initial temperature was 10. So 10 subtract from 20. And we end up getting 10 degrees Celsius or 10 Kelvin. Now, in this case, we can decide which kind of units of temperature we are going to use. We can decide either to use degrees Celsius or Kelvin. We only use Kelvin if the specific heat capacity is given as joules per Kelvin per gram, as you see this one here. So here we can easily use Kelvin because the specific heat capacity here is in Kelvin. But if the specific heat capacity is given in degrees Celsius, for example, if they have given us 4.2 joules per degrees Celsius per gram, if we are given that, then it means we shall use our temperature change as degrees Celsius. But in this case, our specific heat capacity is given in joules per Kelvin per gram, as you see here, as you see there. So therefore, we shall have to use temperature in Kelvin, not in degrees Celsius. Maybe another note we need to make here, the temperature change is always the same. So when you subtract 10 from 20 and get 10 degrees Celsius, even if you convert those degrees, even if you first converted the degrees Celsius to Kelvin, you get the same value. That's why we are saying the answer is 10 degrees Celsius or 10 Kelvin. Reason being, it is a difference. A difference remains the same. Because if we are to convert 20 degrees to Kelvin and then also convert 10 degrees Celsius to Kelvin and then get a difference or subtract, we shall still end up getting 10. So that difference does not change. The difference, the value remains the same, only the units change. Hope you get me there. Let's proceed. Now, when we try to insert in our formula here, we have 100 grams times 4.2 joules per Kelvin per gram. Okay? Hope you understand that now. Now, what we are going to do next, we are going to cancel out similar units. Grams will cancel with grams, Kelvin with Kelvin. So now we shall remain with, we shall have to remain with 100 times 4.2 joules times 10. Then finally we shall get 4,200 joules. If you want to convert it to kilojoules, you'll have to divide by 1,000 and get 4.2 kilojoules. Hope we are together. Let's continue. Let us look at question 2. In question 2, they are asking us how much heat is supplied to change 2 decimeters cubed of dilute sodium hydroxide from 20 degrees Celsius to 40 degrees Celsius. They have given us the specific heat capacity. They have given us the density of water and specific heat capacity of water. But this question, when you look at it, it is silent about the mass of dilute sodium hydroxide. We don't know the mass of dilute sodium hydroxide. We don't know the specific heat capacity of dilute sodium hydroxide. Even we don't know the density of dilute sodium hydroxide. Where are we going to get the specific heat capacity and the density of dilute sodium hydroxide? Because they have given us volume, but they have not given us the density. So what are we going to do? Now there is a very serious note we need to take here before we look at the calculations. For any dilute solution given to you, its specific heat capacity is always equal to that of water. Therefore, the specific heat capacity of dilute sodium hydroxide is going to be 4.2 joules per Kelvin per gram. Reason being that solution is dilute. Hope you get me. Similarly, the specific, for any dilute solution, for example, dilute sodium hydroxide, for any dilute solution, for example, dilute sodium hydroxide, its density is always equal to that of water. So therefore, since sodium hydroxide in this case is a dilute solution, its density is going to be equal to that of water, which is 1 gram per cubic centimeters. And its specific heat capacity is going to be the same as that of water, which is 4.2 joules per Kelvin per gram. Hope you get me there. Now let us look at our calculation. When we come to our calculation, we have our expression for the heat supplied or heat absorbed, which is mc dt. Do we know the specific heat capacity? Yes. The specific heat capacity of dilute sodium hydroxide is the same as that of water, which is 4.2 joules per Kelvin per gram. What's the temperature change? When we try to get the difference, we shall have 40 minus 20, which is 20 Kelvin, or you can say 20 degrees Celsius. I think you know when to use the 20 Kelvin and when to use the 20 degrees Celsius. I said that one depends on the specific heat capacity here. It will depend on the specific heat capacity. Hope you get me. Now, mass. Do we know the mass? No. We are going to calculate that mass. Do we know the density of dilute sodium hydroxide? Yes, it is the same as that of water. Do we know the volume that was given to us? Yes, they gave us a volume which is 2 decimeters cubed. But in this case, we need to convert the 2 decimeters cubed to cubic centimeters. What shall we do? We shall have to multiply by 1,000. Reason being, 1 decimeter cubed is equivalent to 1,000 cubic centimeters. So if you want to convert decimeters cubed to cubic centimeters, we shall have to multiply by 1,000. So we have converted decimeters cubed to cubic centimeters. We are doing that simply because we want these units to match with the density given to us. Because decimeters cubed are not matching with the cubic centimeters, yet we want to cross out the cubic centimeters. So we need to convert that volume to cubic centimeters. Okay, so now let's come to this. We can use our density. We know our density. It is the same as that of water. The volume, we have got this. So volume times density, or volume density times volume, we get to that. So in our calculation here, we are going to cancel cubic centimeters by cubic centimeters, and we remain with 2,000 grams. So it is 1 gram times 2,000 to get 2,000 grams. Hope you get me there. Okay, now we have got our values clearly. So the heat supplied in this case is going to be equal to the mass, which is 2,000 grams, times the specific heat capacity, which is 4.2 joules per Kelvin per gram, times the temperature change, which is 20 Kelvin. we can cross out the similar units. Grams will cancel with grams, Kelvin with Kelvin. And then finally, we come to that. So we shall have 2000 times 4.2 joules times 20. So we shall come up to our heat supplied to be equal to 168,000 joules. If you want to convert it to kilojoules, you have to divide by 1,000. If we divide by 1,000, we shall get 168 kilojoules. So therefore, by following those steps we have gone through, we have been able to calculate the heat supplied. So in this case, that is the heat supplied. So we have come to the end of our lesson. I want to thank you for listening to me. I continue to request you and ask you to subscribe to our YouTube channel. Please like and share, but don't forget to subscribe to our YouTube channel. This is Star e-learning platform, eClass. Please don't forget to support this channel. Thank you for listening to me. May the Lord bless you. We meet in the next